Okay, so here's like I said in the last video, I gave you all the rules, all 6 rules, the generals. There's lots more than those 6, but those are the ones that we're going to focus on. Here's just a power rule. Because power rule is used the most often, I figured I'd do its own distinct video, and then all the other examples we'll put on one little quick video. So let's get through some of these power examples because they're pretty straightforward. Knowing the rule, here I'll put the rule here, ax to the n plus 1 over n plus 1. There's the rule again. So we're going to add 1 to the exponent and divide by that new exponent. So in the very first question here, that's a 1, and this is the same question that we had, is I'm going to have 2x to the 2 divided by 2. The 2's will cancel. My f of x is now equal to x squared. There it is. Okay? The only thing is, I always forget to put the plus c. If I forget, forgive me. Okay? You do have to have it though. It's one of those things. Okay, so let's go to the next one here in the green. We got f of x equals 5x to the 2/3. And you'll notice I'm using that other notation still. I'll switch that up fairly quickly. Anyways, again, it's just a pretty standard one. We're going to add 1. So we're going to add 1 to this exponent. Add 1 to that exponent. So that's 3 over 3. So 5x. If I add 2/3 and 3 over 3, I get 5/3. Now it's divided by 5/3. But when we reciprocal that, we're going to end up canceling those 5's out, and it's going to end up as a 3x to the 5/3 as our final answer. So, see, there it is again. I forgot the plus constant. Plus c. Perfect. All right. So, there's 2 pretty straightforward, like, power rule examples. Just add 1 to your exponent, divide by the new exponent. Add 1 to the exponent, divide by the exponent, and simplify. So on this next one, you'll notice I already took it 1 step further because the variable term is in the denominator. I moved it up and gives us a negative exponent. We're used to doing that. But this time, when I add 1 to the exponent, I get 7x to the negative 2, because negative 3 plus 1 is negative 2, divided by negative 2. It doesn't simplify. If you want to move the negative exponent back down, you can, or whatever. But in my world, plus a constant. There it is. It's as good as you can get. Okay, so you want to try to make it more simple on yourself. So in that case, because you think that 1 over x rule, it would be a ln thing, but you don't have to in this. The only time where you think about the ln rule, the 1 over x, is when the exponent is a 1. So we'll see when we do substitution, and that stuff kind of comes into play too. Okay, so here's another example, and you'll notice I changed the notation. So now I've switched over to f prime. So now when I say the antiderivative, I'm going to say f of x. But this looks a little bit crazy. So now, this is a common type question where we end up using this type of question in substitution lots. But for this one here, because we can factor that top out, x squared plus 5x plus 6 is a trinomial. So x plus 3, x plus 2 over x plus 3. And you'll notice that they cancel out. That's pretty obvious. And we get f, prime of x equals x plus 2. Now it's just 2 distinct terms. And what you'll find out as we go along here with integrals, and I'm not going to maybe do write them all out, but the properties of integrals or antiderivatives, I'll use those words interchangeably, it doesn't matter. The rules are that you can do an antiderivative of a sum. It's sort of like limits, how we had the sum of limits and the difference of limits and the product of limits and stuff like that. It's sort of like that because an integral is actually a sum of limits. So when I go and do this now, when I do the antiderivative of f prime of x here, I'm just going to do the product rule, or the power rule on this term and on this term. Two separate power rules. So you'll see f of x, now that I'm doing the actual antiderivative, I've changed it from f prime of x to f of x. So again, add 1 to my variable exponent and divide by that new exponent. So that x has a 1 on it, so it's going to be x to the 2 divided by 2 plus, I'm going to go up here, I'm going to throw this little sneaky guy in here. I'm going to say this is like saying x to the 0. It's not really there, but we know that it's there. So if I were to do this one, it would be x to x to the 1 divided by 1. Now that's just silly, so we won't even bother with the divide by 1 part. We'll just leave it just like that. And then plus a constant. And there would be your antiderivative. So again, you could check this out. You could go and do the derivative of this, and if it works out to x plus 2, you know you did it right. Okay? You can always prove that. Okay? Okay, so we've got a product of two binomials, and again, you can make anything simplified if you want to. And in this case, this would be a perfect example to actually multiply everything out. So I'm going to go and do that just so I have single terms that I can just use the power law on. So when I distribute everything here, I get 15x squared minus 12x minus 10x plus 8. We'll go a bit further. I'm still using the derivative notation because I haven't done the antiderivative yet. 22x plus 8. Now that I've got three single terms, I'm going to use the sum of integrals, or sum of the limits of sums, all that stuff. It doesn't matter. It's like doing three individual questions here. I will change my notation because I'm doing the antiderivative now. I'm going to add 1 to my exponent, divide by the new exponent, add 1 to my exponent, divide by the new exponent, add 1 to my exponent, divide by the exponent, but it's a 1, so I'm not going to change anything. And then I will simplify, and when I'm done my simplification, I will put the plus a constant in there. So 15 divided by 3 is 5, minus 11x squared plus 8x plus a constant. And again, all you have to do to check is go and do the derivative of that, and I'm pretty sure you can see it without actually even doing it, that is the derivative of your f of x function.